Okay, day 2 of 14.3, doing our SOHCAHTOA. Pretty much just word problems today, still using the same information as yesterday, SOHCAHTOA, making sure we have right triangles. So this first example talks about the Louvre in Paris. Has a square base, angle formed by each face, and the ground is 49.7 degrees. That is right here and here. I want to know the distance from the center of a side of the base to the top. So I want to find this. This is my x. Well, like I said, we want to deal with right triangles. So I want to look at this triangle right here. Here's my right angle. This whole side is 35. So if I only want this length, I'm just going to half 35 to get 17.5. So that's just half. Okay. So I know my angle. I know a side. I just need to figure out how x relates to my angle. Well, it's opposite. 17.5 is adjacent, so I'm using tangent. Okay. So the tangent of my angle, I know my angle. My angle is 49.7. So the tangent of 49.7 is opposite side, which is x, over my adjacent, which is 17.5. Like we did yesterday, multiply 17.5 by each side. And so x equals 17.5 times the tangent of 49.7. If you put that in your calculator, you should get 20.6 meters. Okay, if you're not getting that, make sure your calculator is in degrees, not radians. If you get a negative number, a lot of times that is what the problem is. Okay, problem 4. We have an airplane who has an angle of descent of 3 degrees. So we got a little airplane here. Awesome picture. It is coming in at this angle right here, and that is a 3 degree. It's kind of confusing why it's on the outside. This angle right here is our angle of descent, not the one inside of the triangle, but they are parallel, and if you remember your geometry, that makes this interior angle right here 3 degrees. Okay, I know it's probably been a long time. Whenever it says angle of descent, that's always this angle here. Always. It's always outside of our triangle. It says it begins a descent at an altitude of 4,000. So that's how high my plane is. This is a right angle. I want to know what the straight line distance is. So that is this side right here. Well, how it relates to angle, my angle 3, 4,000 is opposite. My x is my hypotenuse. So I'm using sine. My sine of 3 is opposite 4,000 over my hypotenuse x. Kind of the same idea as the one before. Multiply by the bottom of your fraction. This time it's an x. So I have x sine of 3 equals 4,000. Well, just like yesterday, we treat the sine of 3 like any other number. So we just divide to get x by itself. So I have 4,000 divided by the sine of 3. When you put that in your calculator, you should get, I'm going to write it over here, 76,429 feet. And it should be a big number because we are coming in at a really low angle of 3 degrees. So considering this is 4,000, it does indeed make sense that we have a huge number. Looking for the trigonometric ratio here involving angle A. I want to know how angle A relates to 4 and to 10. Well, 4 is opposite, 10 is my hypotenuse, so I'm using a sine again. The sine of angle A is my opposite 4 over my hypotenuse 10. Now, I don't know if you talked about this last year in geometry, but to get A by itself, right now it's attached to sine. I want the sine to go away. Well, there is this thing called inverse sine. It looks like this. It's probably, if you hit on your calculator, if you hit the second button and then where you normally press sine, you'll probably see this sine inverse, okay? Now, sine inverse or cosine inverse, this inverse -1 exponent always tells us an angle measure, okay? So we always use the inverse to find an angle. Okay, so if we take the inverse of our fraction, so if you type this into your calculator, inverse sine of our fraction, you will get your angle measure of 23.6 degrees. Okay. Next, we have triangle ABC where C is a right angle. We're going to draw a picture. If C is the right angle, I'm just going to call this A and B. Doesn't matter as long as C is your right angle. Angle B, it tells me, is 20 degrees. And A, not angle A, but side A, is 6. Now, sides, letters always correspond to opposites, okay? So opposite my angle A is my side little a, which is 6. So like this side right here would be little b, this side right here would be little c. Okay, so always opposite our angles. What we are trying to do is find angle measures and sides, everything that we're missing. So if we remember our geometry, to find angle A, triangles add up to 180 degrees. I know two of my angles, so I'm just going to take 180 minus right angles equal 90 minus my 20 degree, and I get angle A to be 70 degrees. So angle A is 70. So I know all my angles are done. To find, let's do side B first. So this is little side B, this one right here. Okay, you got to figure out how it relates to, I'm going to use angle 20 since that's the one we were given. I got to figure out how it relates to that. Well, it's opposite, and then the 6 is adjacent. Opposite and adjacent, I'm using tangent. So the tangent of my degree I know is 20. Opposite is B, I don't know it. My adjacent is 6. Again, solving like yesterday, multiply your 6. Put 6 times the tangent of 20 in your calculator, and you get 2.2 for your side B. To find the little side C, you can use trigonometry again, or you can use Pythagorean theorem. I'm going to use Pythagorean theorem just to kind of switch it up. So a squared plus b squared equals c squared. Looking for my c, I don't know my hypotenuse. So 6 squared plus 2.2 squared equals c squared. My c squared is 40.84 when I square and multiply, or I'm sorry, square and add. So my c is 6.4. And those are all my missing sides and angles. Okay, my next triangle, again, you can draw your triangle any way you want, just as long as C is your right angle. Fill in the stuff in a little side B, it's across from our angle B, so that's 7. Hypotenuse is 10. I'm going to find side first, because that's what's missing. I'm looking for little side A. So a squared plus my other leg that I know is 7 equals my hypotenuse squared. 10 squared 100. Split that up here. So a squared gets to be 51. So a is approximately 7.1. Okay. This time we do want to find square roots because it says we want them to the nearest 10th. So yesterday I had to leave them in radicals since we're not really doing anything with them. We're just going to put them into decimal form. Okay, I know one angle is 90. Let's find angle B first. This one right here. I just like to go based off of what was given to me. You can definitely use side A, which is 7.1. I'm going to use the stuff that's given. So when I look at angle B, what's given is 7, which is opposite, 10, which is hypotenuse. That is sine. So the sine of my angle is 7 over 10. Again, to find angle measures, you're using that inverse thing. So the inverse of my fraction, put that in my calculator, and I should get 44.4 degrees for my angle B. And then to find A, again, triangles add up to 180. My other one is 90, so when I subtract 90 and 44.4 from 180, my measure of angle A is 45.6. So almost a 45, 45, 90 triangle, which makes sense because leg of 7, leg of 7.1, those are pretty close, so our angles should be about the same. And last problem, we have a ramp, and we want to know the maximum angle and how long the ramp must be in order to meet regulations. This is actually a huge thing, very applicable. So it says my entrance is 6 feet above ground level, so my rise is 6. It also says 30 feet from the roadway, so my horizontal is 30. So this little triangle here, that's my right angle. First, let's find the maximum angle. Well, that's this. That's the angle I want to find because it says with the ground for the slope. Okay, so ground, this is my angle I'm looking at. This one right here. So how does 6 and 30 relate? Well, 6, my angle is opposite, 30 is adjacent. I got OA, so I'm looking at tan. The tan of my angle is 6 opposite over 30 adjacent. Again, looking for angle, so using inverse of my fraction, and I get an angle of 11.3 degrees. And it shouldn't be very steep. I don't think I've ever seen a super steep ramp. Last thing I want to do is find how long the ramp must be. So finding this, well, that is just a Pythagorean theorem. Easiest way to solve. You can solve using trigonometry. I'm going to solve using Pythagorean theorem. Either way should work. That is my hypotenuse. So that is the thing that goes out by itself. 6 squared plus 30 squared equals c squared. And doing math, square root, I get 30.6 feet. Okay, if you have questions, make sure to circle them. Feel free to ask. Your homework is page 916, 917. It is, again, those pages are on Classroom. Numbers 12, 19 through 25 odd, 35, 36, 41, 43. Make sure to ask if you have questions. I will be back tomorrow.